So, in today's lecture, we will understand about mechanical properties of what? Solids. First, we will discuss about solid. Then we will move and regarding study about fluid and then thermal properties. So, first thing, what is solid? When we are studying properties of solid, what is solid? A solid is something which have their atoms in their fixed lattice. So, when we say that the atom is in fixed lattice, so there is a phenomena comes when we apply a force, then the material will be deformed or irregular, their configuration will be changed. Why the configuration will change? Because in previous chapters we are saying that when we apply a force, then the position, displacement, velocity, all the other factors are there. So in mechanics, there is three branches: statics, dynamics, and third one is kinematics. So in previous chapters we are understanding about kinematics, where time is a factor, and in dynamics there is also time is a factor, but in statics there is no time consideration. What is the meaning? If there is a material who is under stress, what is stress? There is a term stress. We will discuss it. What is stress? So when any material is under some load or some any conjunction, then what actual inside the material is happening? Firstly I told that material is solid have in fixed lattice. So atom is in fixed lattice. So what is stress is doing in this case? When we apply the force, that either is perpendicular to the cross-sectional area or either it is parallel. According to the application of force, either it is parallel or perpendicular, there will be a stress. So what is stress? Stress is force upon area. So this force is that we apply the force. That is the force? No, that will be not the force. This force is internal force. There is a restoring force, because the atom of a solid is in fixed lattice. It will confine in their original configuration. So for remaining in the original configuration, there will be a force which is internal force or restoring force. It can be said as internal force or it can be said as restoring force. So this force is not that force that we are applying. This force is internal force. So internal force by area. So you can apply force by three ways. तीन तरीके से force apply कर सकते हैं. First, when you are applying the force perpendicular to the cross sectional area, or either you are applying force which is parallel to the area, or in all direction. There is three application of force is three types: either perpendicular or parallel or through both sides. So when you are applying force perpendicular to the cross sectional area, this is normal force. This is surface, and cross section area vector of this surface is perpendicular to that direction. So when you are applying the force in the direction of area vector or in the normal component to the force, then this force is called normal force, and stress type is normal stress. What type? Normal stress. When you are applying force normally, the stress will be normal. You can say normal stress, you can say longitudinal stress. Why we are saying longitudinal stress, we will discuss later on. But when you are applying force normally to the surface, then this stress is called normal stress. When you are applying parallel force, this is parallel, where area vector and application of force is perpendicular to each other, or where surface and your application of force is in the same direction. Look at this. You are applying a force parallel. When you are applying a parallel to area vector or perpendicular to the normal force, the deformation will be compression or tension. You can apply normal force by two directions. Either you are applying compression or you will apply tension. So there is two type of normal forces. One is tensile, where length of the material will increase. Another type is compression. So when you are applying normal normal to the area vector and parallel to the surface, then what is happening? If you are applying a force which is parallel to the surface, then the shape will be changing, angle will be changing. So in this force we call tangential stress, when the application of force is parallel to the surface or normal to the area vector. So this stress is tangential stress. Another one is when you are applying a force through whole direction, entire direction, all sides. Likewise. So in this case, volume will be changed. No shape deformity will happen. Only volume will change. Shape will be confined as previous one. Shape will remain same, but volume will change. So this stress type is called hydraulic. What is hydro means? Water. So water applying a force in FM, in fluid mechanics, or in your syllabus, this is known as mechanical properties of fluid. We will understand how pressure is related with the bulk modulus. So another type is hydraulic stress. So there is three type of stress: normal stress, tangential stress, and hydraulic stress. Depending on application of force, there are three type of stress: normal stress. Normal stress can also be said as longitudinal stress. Tangential stress can also be said as shear stress. And third one is hydraulic stress. There is three type of stress. What is strain? When we are pushing you in some way that you will study hard, you will feel pressure. In that pressure, what you will do? You will compromise with your daily activities. You will adjust some time from here and there. So in this situation, material when under compression and it is beyond their capacity, it cannot hold their shape. So it will change their size, shape, or dimensions. In that case, there is strain in the body. There is strain in the body, and strain is change in configuration upon original configuration. Change in configuration upon original configuration. Why we are saying configuration? Because when you are applying normal force, the size will be changed. So change in length upon original length is the time where you apply a normal force, and that strain is called longitudinal strain. That strain is called longitudinal strain. When the application of force and the change in length will be in the same direction, then stress will be called longitudinal. There is another type of strain, that is lateral strain. Suppose when you are stressing a wire, the length will increase, and when length will increase, the width will decrease to remain volume and constant, because there is no addition of material. You are not adding any material here, so volume remain constant. So when volume remain constant, when you are changing the length, you are increasing the length, then width will decrease. So this type of strain is called lateral strain. When the application of force and the change in configuration is in same direction, that is called longitudinal strain. But when application of force and the strain type is perpendicular, then that strain is called lateral strain. Clear? So when we are applying normal stress in the direction of application of load, there is a strain, and the direction and the strain type is called longitudinal. And when the application of force and strain is in perpendicular direction, then strain is called lateral strain. There is another type, tangential stress, where you are changing the shape of the body. So there is third type of strain, that is when you are changing the angle. There is a relative motion between the 2 points, initial and final point. The shape will change. One end is fixed, another end is not fixed, another end is moving. Then there is deformity in the body, and then deformity is called strain. What type of strain? Shear strain. What type of strain? Shear strain. Another type where you are applying a stress, to whole direction, then the stress is called hydraulic stress, and strain type is called volumetric stress. There is three type of stress: normal, tangential, and volumetric strain, that we call hydraulic stress. There is three type of strain: longitudinal, shear, and volumetric strain that we call volumetric strain and or bulk strain. So there is three type of modulus. We will discuss in next class.